respected teachers, and all my dear friends. Today, my presentation is on underwater metro. Myself, Dipanshu Pandey from Civil Engineering, third year. It is presented to Engineer Kosles Kumar Sasan, subject in charge, Department of Civil Engineering, kmclu. This is the image from where metro will run. Introduction. Proposed by KMRC, it has a stretch of total 16.6 km. The underwater tunnel is 520 meter, which passes through the Hooghly River. This is the representation of where tunnel is situated at which level. You can see from riverbed, the depth of tunnel is 13 meter. The length of each river tunnel under the Hooghly is 520 meter. The dia of each river tunnel is 5.55 meter. Takes less than 60 second times to cross the river tunnel. 80 km per hour proposed maximum speed on corridor. It takes 67 days for tunneling from April to July 2017. Alignment and progress of Kolkata East West Metro. There are 12 metro stations along the corridor route from Howrah Maidan to Salt Lake Stadium. All are underground, and from Salt Lake Stadium to Salt Lake Sector 5, all of which are elevated. Contractors involved in this construction are Afghan's infrastructure and Russian firm Transtunnel in a joint venture. Afghans is also responsible for the construction of three underground stations and other works on the project. The two tunnel boring machines were ordered from Herenet. ITD Cementation constructed a diaphragm, also known as a D-wall in engineering parlance, which is needed to connect the station to the tunnel dug by the TBM. Crossing the Hooghly. When one steps out of Howrah station and heads towards the city, one is faced with the daunting task of crossing the Howrah bridge. However, teeming with every kind of vehicle possible, the bridge has become a dreaded prospect for every Kolkata Howrah bound traveler. This is where the East West Metro comes in with an alternative which combines an almost dreamlike appeal with uncompromised efficiency, traveling more than a 10-storied building below the water surface for almost half kilometer across the Hooghly. This marvel of modern technology is a resounding first in India as well as a rare venture worldwide. Design and construction of India's first underwater tunnel. The tunnel will have an internal diameter of 5.55 meter and an external dia of 6.1 meter. The spacing between the tunnels will be 16.1 meter center to center. The inner walls of the tunnel are being made with M50 grade reinforced concrete segments with a thickness of 275 mm each. Six of these segments will complete a circular lining of the tunnel's dia. The segments are being precast in specialized molds imported from Korea. Several protective measures have been taken to prevent water inflow and leakage in the tunnel. Concrete mixes composed of fly ash and microsilica have been used for the segments to minimize water permeability. The segments are being sealed using a complex grouting process that will fill the space between the segments and the shield of the tunnel boring machine. A two-component grout mix including slurry made of water, cement, and bentonite and sodium silicate is being used to fill the gaps. An engineering feat worth being proud of. You can clearly see that the TBM which was used to tunnel the riverbed, the two German Herenet mid-tunnel boring machines TBM S640 Christian Prerna and TBM S639 named Rachna that dug the east-west metro tunnels under the joining Howrah to Kolkata. The Howrah metro station on the west side of the river will be a depth of 30-meter tunneling started from Howrah Maidan site. Boring the twin underwater tunnels. Boring the underwater tunnels, which are predominantly composed of soft and stiff clay, has been one of the complex challenges of the project. Equipped with earth pressure balancing capabilities, the machines are suitable for projects on unstable terrain or under structures that are sensitive to ground disturbances. They can withstand three times more atmospheric pressure during the boring process. Each TBM is 8.5 meter long, as tall as a two-story building, and has backup gantries extending to 100 meter. Six generator sets of 1010 kVA will supply power to the boring machines which are equipped with 5 motors exceeding 650 horsepower and more than 35 other auxiliary motors. The TBMs will bore up to 15 meter a day, excavating up to 500 meter cube of the earth to complete 2.9 meter of the tunnel. The two TBMs bored the east and westbound tunnels in a record span of 66 days from April 2017 to June 2017. While the first tunnel crossed the river in May 2017, the second one crossed it in June. The underwater tunnel construction is technologically comparable to the Eurostar high-speed railway service that traverses the Channel Tunnel between the UK and France. The TBM S616 Urvi was deployed in March 2021 to construct the final stretch of the East-West Metro 70 meters below Sialda station. On 23rd May, one of the TBM named Rachna completed the tunneling under the Hooghly River in 36 days. The other TBM named Prerna also completed the tunneling work under the river on 21 June 2017. This is the actual image at underground section start from Fulbagan to Howrah Maidan. Challenges: putting the tunnel below the Hooghly River was difficult as it contains water the year around and the pressure varies there because of the fluctuating depth of water. Planning and working around obstacles. When digging work was started for the tunnel, the first layer of soil was deemed unfit for construction. This was because water could easily drain through it as opposed to the clay layer, which is composed of the smallest particles of soil, which are densely packed with little or no air space. Fortunately, clay soil was found in the second layer and the tunnel could be built. Talking about the ventilation system for the underground network, Samim Ahmad, General Manager Electrical KMRC, told the print that the KMRC team analyzed the database of maximum and minimum temperature and humidity in the city on the basis of which the system was designed. Ahmad said no water was diverted in the process of making the tunnel and waterproofing had been done to avoid incidents of flooding or leakage. According to the KMRC, emergency evacuation pathways are also available in the tunnels with exit arrangements and Howrah Station and Strand Road. A stitch in time. Despite the precautions and planning, the KMRC team and workers did face challenges in the process of constructing the underwater tunnel and section of the metro line that passes through congested areas along the Brabant Road in Burra Bazaar. A millimeter by millimeter land survey had to be conducted for the construction of the underground tunnel so as to not infringe the foundation of the Bankim Setu. This was done with help from the earth pressure balanced tunnel boring machines. Apart from the Bankim Setu, there was the Brabant Road flyover which started Howrah Bridge. Again, the metro tunnels had to build below it without affecting the bridge foundation. Cost of project. As far as the cost of construction of the underground metro is concerned, it cost about rupees 120 per kilometer to build the tunnel, but the manufacturing cost of the tunnel underwater, which is deep in the Hooghly River, cost increased to around 157 crores by per kilometer. It is built at a cost of rupees 10,442 crore. Safety measures inside the underground tunnel. Emergency evacuation shafts up to 760 meters in length are being provided inside the tunnel to adhere to National Fire Protection Guidelines. The evacuation shafts are being provided in Howrah Station in the west and Strand Road in the east to improve passenger safely. State-of-the-art tunnel ventilation system are being installed to ensure adequate ventilation during emergencies. Thank you so much.